This was all about the rules. Now I'll give you some questions. Just try it out. First one is log 64 to the base 4, log 27 to the base 3, log 81 to the base 27. Fourth is log 0.25 to the base 2. So just try this 4 questions out. This is very simple ones. We'll do some typical ones after this. So in the first problem you can see that this is nothing but log 4 to the power 3 to the base 4, right? So what we want to do here is we want to introduce the same number in the base and the number, so that we can eliminate this power by writing it as 3 log 4 to the base 4. Now we know that log number to the base the same number is equal to 1. So this is nothing but 3 into 1 is equal to 3. So what we did is we introduced the same number as the base in this inside the logarithms, and when we introduce this power in the front, when this power came in the front, this became log 4 to the base 4, which is nothing but 1. So this thing can be similarly solved like 3 to the power 3 to the base 3, or 3 log 3 to the base 3, which is nothing but 3, right? So this is how we do such problems. These two are a little tough problems. Just try them out. Log 81 to the base 27 and log 0.25 to the base 2. So the first problem can be seen like this, that this is becoming log 3 to the base 4 upon 3 to the base 3. Now we just recently did this formula, log a to the power m upon b to the power n, right? Log a to the power m to the base b to the power n. This is nothing but 4 upon 3 log 3 to the base 3. This is nothing but 1, so this will become 4 upon 3, right? This can be written as log 1 upon 4 to the base 2, right? Which is nothing but 2 to the power minus 2. I guess everybody is able to understand why I write it as 2 to the power minus 2, because it can be written as 1 upon 2 square. Now because this is in reciprocal, this can be written as 2 to the power minus 2. Now this thing is minus 2 log 2 to the base 2, which is minus 2 only. So these are the values. These are the answers to these questions. So let's try some more questions. So the first one is, determine the value of this expression log x upon y plus log y upon z plus log z upon x. You have to tell me the value of this one. The next problem is log x to the base y multiplied by log y to the base z multiplied by log z to the base x. So just try these two problems out. So in the first question, you will just have to apply the addition formula for logarithm. You know that log m plus log n is equal to nothing but log mn, right? So this can be written as the product of these three numbers written inside the logarithm. Since the individual logs are getting added, the numbers inside the log will be multiplied. So this is log x upon y multiplied by y upon z multiplied by z upon x. These all will cancel out because they are written in the circular fashion. So this is log 1, which is nothing but 0, right? Now this will be visible that which rule of logarithm which will be used in which question. Like in this question, the addition formula is used. Now in this question you can see that the bases are different in all the cases, right? In this case the base is not mentioned, so it's not mandatory to change the base, like the base changing formula is not needed. But in this case the base changing formula is needed. So this will be written as log x upon log y multiplied by log y upon log z multiplied by log z upon log x. So all these will cancel out and the result we'll get is 1. So this expression is coming out to be 1. So in the first problem we just use the